Hey, in this video I'm going to be looking at the Firebase function I use to receive data from the various IoT backends, whether it's the Things network for LoraWan, Sigfox backend, or hologram for NB-IOT data. It all comes into the same Firebase function that's a HTTPS endpoint, gets processed and loaded into my Firestore database. And also have a quick look at the components I created to support that. So I've got devices, device types, and sensor to be able to interpret that data coming in and make sure it gets to the right place in my Firestore events collection. Okay, let's have a look at the Firestore structures and the UI that I set up to support the data acquisition. So up the top here, this is these pieces I've built in the UI. It's changed a bit from the last video, but I do have users, which are part of FM Starter, but I also now have user groups where I can tie users to user groups. Also got these three structures. So the first one is data types, so that's device types. So that defines generically what a certain device looks like, and that device type has a sub-collection of sensors. So this is the definition of the sensors that I'd expect to have with that device type. And again, it's used during acquisition to work out what sensors should be present, where to find that sensor data, how to store that sensor data in the events. And then the other structure is this device collection. So these are actual devices of a certain device type, and includes information like a way of identifying that device with the device ID. Also has a default latitude and longitude of that where that device is currently located. So let's have a look at the UI I created. So in our LoRa, you can see here we have this user groups, not a good name for my user groups. We have device types. So here's a couple of examples of device types. So I've got one for the boat monitor that I'm going to build using the PyCom board, and also this one here, which is letterbox monitoring device. I'm actually going to work through this example first in the rest of the videos, and then bring the boat monitor in. But it's a LoraWan device, so I'll be going through the Things network, and the main thing it does is detect doors being open, closed. So I've put it on my Mailbox, and the two pieces of sensor data that I get from it is a door sensor, whether the door is in open or closed state, so that comes through every time someone opens or closes my Mailbox. And then the internal battery sensor on that device. It should last a really long time, but I still want to keep an eye on the battery so I know when I need to replace it. So like I say, device types is just a generic device type, so that I may have multiple devices that are of this device type if I have more of these switches I want to use around the house. So the other piece here is devices. So again, if I look at my particular Mailbox device, it tells me it's using that device type that I set up, and I can choose from that device type or the boat monitor if it happened to be the boat monitor type device. The IoT data source, like I say, at the moment this is coming through LoraWan, so coming through the Things network, but I can choose that it can come from other IoT data sources as well. So again, that's used in acquisition because it deals with the data coming in certain different ways, depending on what backend it's coming from. They format the data slightly differently, and this device has a default latitude and longitude. Let's just have one more look at this device types and this door sensor. So the door sensor has some information for the actual sensor, so where to look for the timestamp on the data coming in. So again, this could be different from one sensor to another, or definitely will be different from one device to another, is how the timestamp gets recorded, what field it goes into, and also for, in this particular case, the door open status. It comes in on a field called payload fields door open status. So this is how I defined where that particular piece of data comes from. If that sensor also provided latitude and longitude, I can specify what fields I'd look for that latitude and longitude, and that's the location data that would be written to the event data. So this shows me using Sigfox and sending the resulting packets from my device that's running. You can see it there up in the upper right corner, through Sigfox to my Firebase function that's getting processed and then being put into the event data. So we can see here the actual message that came through. Shows me that the callback was okay, what it sent in the callback. So this device sends latitude, longitude, provider string, which is Sigfox, and the device ID in the payload fields in the callback section. So if we see here, go into the edit, we can see this is the configuration for the callback section for Sigfox. So this is calling back to a website. The changes I had to make was to add the authentication header and to change the content type to application JSON, and here's the little piece of script that formats the body. So if we see the result here, this shows me my Firebase function and the various comments I put into it as it processes the data coming in. So we see the headers and the body fields of the data coming in from Sigfox, where it recognizes the device ID, the device that it matches up, and then from that it can find the device type and the sensors collection, and then from all that it works out what event to write to the event data store. And if we go over to Firestore, we see under the events collection we now have one document, which is the one it just wrote, which has all those fields that were derived from the information coming in. If we have a look at ourLora, for that device, which is this one here, my boat, it's using the boat monitor device type. So let's look at the boat monitor device type, and the two sensors is this latitude test and humidity. So the latitude test would be the only one that's matching up, and here it's getting the value based on the payload fields.lat, and the payload field .lat and long are used to see if an actual longitude and latitude is coming in from the device, which is used in preference to the actual device location, which is more static. So this is useful if a device might be moving around like a boat monitor. Okay, and then we see the same thing with my letterbox sensor. I open and close it, and in this case it's using LoraWan, so it's coming through the Things network. So we see in my cloud function log, the body coming, in this case, coming from the sensor that's in the Mailbox, comes through, writes out event data again. If we look at Cloud Firestore, where the event data goes, we see the data being written out, and this is the particular sensor for the open close, so it's got a value of 1 when the Mailbox is open, which you'd expect, and the date and time stamp on that one, as well as references to device type, and the location of this case, the actual device definition of the location. And if we look at ourLora, we see here's the setup for the sensor, where it's looking in the payload fields for door open status, and that's what gets written to the event. So let's have a look at the actual code. Okay, the code for processing the IoT data coming into my Firebase function shown here. So it's under, in my project, under functions, under source. Source contains the actual logic, as well as a models folder that has a copy of the device type, event, and sensors models. So those are pretty much the same as in the main Angular project's definition. So initially you define functions that are going to be used in the index.ts under source. So it just shows here that I'm using the Mailbox function from the acquisition library, and acquisition library is where I wrote the code. So let's do a Control K Z to go into Zen mode so we can concentrate on the code. So this is the code for the acquisition function. So here we see those various model libraries being used. So just running through it. So I've called the main function Mailbox. It's probably not a great name for it, but it'll work for now. So you call ourLora Mailbox to be able to send data to this this function. So the function implements an on request, so it'll receive any requests being calling that function, and can also send responses. As we saw at the start of the function, it'll show you the headers and the body of the request HTML coming in. The next three statements here are just doing some top level verification that doesn't require any lookups to the database, so it's checking that it has the correct authentication header. Again, I'll change that to something else when I get closer to production. That's very basic authentication. The content type has to be application JSON. It expects the body to be a JSON object. It will drop out if it's not, and also expects there to be a user agent present. The next part is just a big switch statement where it drops through the user agent to work out where this IoT data is coming from. So looking at the first, so first it splits the user agent by backslashes, and then looking at the first part of that past user agent, if it contains Sigfox, then it tells me it's coming from Sigfox. So I set the IoT data source to Sigfox, and pull out the device ID. So where it comes from in Sigfox is different from some of these other IoT backends. So Sigfox, it gets it from payload fields device ID, and it says here when you're setting up Sigfox, the Sigfox interface, what you need to do in the JSON script to get that device ID in the right place. If it's coming from the Things network, so the user agent will start with HTTP-TTN. Again, I set the IoT data source to the Things network, and in this case the device ID is coming from request body dev ID. I have a data source for curl, so you'll see up here, just for testing this, I'm able to invoke this function using this curl string. So this was useful for testing, so I don't have to keep firing off my IoT devices to get everything to work. So this will, the statement down here, switch statement, will look for it coming in from user agent curl. I should set that the IoT data source to curl, mistake there, and I pull the dev ID out of the payload fields in this case. And finally, if it's not any of those, then it's an invalid user agent. I still need to add one more in for NB-IOT once I get that working and get an idea of what the data looks like coming into the system. If it found a device ID, then it's going to call prepareAndWriteEvent. So that's the next routine down there. If it doesn't, it's going to give me different error messages and not process the data. So let's have a look at this prepareAndWriteEvent. So in this case, I've got a device ID, I've got the IoT data source worked out, and I've got the request body coming in. So one thing I'm going to do is I'm going to set the timestamp so that all my event documents that get written out with the same timestamp. That's just a way of correlating events. And that's actually going to change my user interface later on. I'm not going to be pulling the timestamp out of the actual sensor data coming through anymore. I'll just be using the timestamp that's on the server. This one set here. And now I go through and I'm going to look up the particular device type and sensors associated with that IoT device. So first I look up to see whether I've got a device that has that device ID. And you see if it's found, then it returns the device. If the device is found, it does a quick check to see that the IoT data source, so whether it's Sigfox, the Things network, etc., where it came from actually matches what the device is set for. It's the source of the data for that device. If they don't match, then it gives an error back. Otherwise it carries on. If we've got a device, then it looks up the device type, much the same way. By the way, I'm doing all these things synchronously. It makes it a little slower, but really doesn't affect the performance for this sort of thing much. So these things can happen fairly much in the background. They don't take long anyway. So I go through, look up the device type, and then if I find the device type, I also look up the sensor data, or the sensors associated with that device type. If all those things are found, then it's going to call the writeEvent. Again, I'm using a wait to make sure it's synchronous at this stage. So it's going to call the writeEvent and pass all the things I've looked up: the device type, sensors, the IoT data source, the request body, and the timestamp all get passed over to this routine. So in this routine, I go through each sensor associated with the device type one by one. I look to see if the sensor matches data that's meant to be coming in. So I look at the sensor acquisition map value. So this is the property name of the property that holds the value in the body JSON. If it finds it, then I know it matches up with that sensor's definition of what data should be coming in. It's using this get body field routine, which is down here. So this is a little routine I wrote to make it easier for getting the data pulled out of the request body. I had to do a little bit of manipulation on the getting the property, converting the way I define it in the UI to what it actually needs to do to pull the data. So if it finds the sensor matches, and it sets the value to what that value property is called, or what is contained in that value property. One more thing I do, I think I showed it earlier, was every sensor event has a location as well. So that location either comes from the device by default. So it's device is going to be a static location just where that device by default is located. So it pulls the device latitude and longitude. But if we say, again, in the sensor definition that latitude and longitude is coming from a sensor, so for example a GPS sensor in my boat monitor where things can move around, in that case I'm going to use that latitude and longitude rather than the default device latitude and longitude. So first looks to see whether I've defined that sensor has a latitude and longitude. If it does, then I try and pull the latitude and longitude. So sensor latitude, sensor longitude is set. If it found those two things, if it's found the sensor has a latitude and longitude, then I use those as the latitude and longitude rather than the default device one. And then the final thing I do is write out the actual event. So you see I just create a event object, set all the values in there. So it's setting things like the timestamp, the location, which is set using the latitude and longitude. That's actually stored as a geo point in Firestore. Stores the unit of measure, reference to the original device and sensor. I can also derive the device type reference from the sensor reference, and then writes out the event. And that's what we saw in the earlier videos, where the data gets written out. That seems to be working okay, at least it's good enough as being an MVP type version of it. I'll probably need to put some tries and catches and things like that in it, but that's the bulk of the cloud function that does the data acquisition from the IoT devices. So next videos will be more about the UI to process the event data, so setting up things like triggers, looking at trends in the data, and also I'll have a look at using NB-IOT from my device to send data, as well as Sigfox and the Things network.